Lecture 9 and everybody's favorite, Nomenclature. We're almost done. There are 10 for this summer assignment thing, plus 5 more giving you answers to the packets, so lecture-wise we're doing great. We're starting off with ionic compounds. Coming from your periodic table, if you remember, cations are positive, like cats have paws. So a cation is a positive ion. How does it form? If you think it through, remember the charges on protons and on electrons are equal. So if I have my charges canceling perfectly, I have a neutral atom. If I lose electrons, there are unpaired positive charges, and that's how you get a cation. An atom loses electrons. It leaves behind uncanceled protons and a positive charge. Most cations form from what type of elements? Metals. So when you're looking for cations on the periodic table, they're going to be left and center. Anions are the opposite. They're negative ions. They're formed from gain of electrons. The electrons bring their negative charge and there's no proton to cancel. Anions are normally from non-metals. So when we're looking at an ionic compound, they're often made up of a cation and an anion, or a metal and a non-metal. And we always put the cat first. There's a rule in my house, if you're going down the stairs with the dog's an 80-pound bowling ball. Dog goes first. Dog has to be the first one down the stairs. When you're writing your compound, the cat goes first, as in cation. So your cation's going to go first, then your anion, positive, negative. It's the way you read. Metal, non-metal, when you're writing an ionic formula. We like for atoms to have a number of electrons equal to a noble gas. Look at group 18, 2, 10, 18, 36, 54. Because noble gases have stable numbers of electrons. So this determines how many electrons something loses or gains. The goal is to get to 8 outer shell electrons. 2s electrons, 6p electrons, 8 total. We like that. So when we start looking at losing and gaining electrons, the number of electrons lost and gains are going to give an element that number, that stable number, as easily as they can. Atoms are lazy. We want to do as little work as possible. So if we have less than 4 valence electrons, we're just going to lose them. We're going to get rid of them. If we have more than 4, we're going to gain them. So look at your periodic table. You would have 4 valence electrons in group 14. Carbon's going to be your dividing line. Carbon's going to be your dividing line here. So if I am to the left of carbon, I'm losing electrons. If I'm to the right of carbon, not group 18, it's already good. To the right of carbon, I'm gaining electrons, and that's where we're going here. We are going to look at valence electrons and those ideas more later, but for right now, you're looking at groups 1 and 2, which in the periodic table, the 2 over to the left, and then we're going to look at the P block, groups 13 through 18, the blocks on the right. So 1 and 2 are S blocks. If you don't remember that, look that up. The S orbital's filling over to the left, and we are coming back to orbitals later too. This is not the only time we'll talk about that. And 13 through 18 are over at the right in the P block. Good. Cation or anion? Let's see. If I have less than 4 valence electrons, or if I'm less than group 14, I'm going to lose electrons and be a cation. And 15 and above, well, 14, I don't even think 14's on your chart. You don't even have 14. Aw, and you don't have 18 either because they're not doing anything. So we got anions here. Those are gaining electrons. These are losing electrons. How many are we losing? Group 1 is going to lose 1 electron for a +1, or 1 plus. Group 2 loses 2 electrons for a 2 plus. And group 13 loses 3 electrons for a 3 plus charge. 15 and 16, 17, we basically turn it around. Group 15 is going to be 3 minus, 16, 2 minus, and 17, 1 minus. Now, when you're doing this for right now, accept it. If you don't remember the why behind this, look it up, or we will come back to it. We're going to go over that all together. But for right now, I just want you to have that, because it's hard to do formula writing without those. If you've got a printed periodic table, you're welcome to write those down on your periodic table for now. You won't be able to use that one on exams, but to have while you practice, it's not a bad idea. So let's see what we can do with formula writing because of this. Remember, when we're writing formulas, we just want the charges to be equal but opposite. So if I look in my examples at lithium and oxygen, lithium's group 1, so plus 1, oxygen's group 16, so minus 2. I cross those. If lithium is plus 1, 1 plus. Oxygen's 2 minus. I need to make them equal but opposite. So I'm going to need 2 plus 1s to cancel out a minus 2. That's like math class. 2 times 1 cancels out minus 2. So I need 2 of those and 1 of those. Li2O. My other example, aluminum and fluorine. I need 3 minus 1s to cancel out plus 3, AlF3. Let's look at these examples. We've got calcium and oxygen, potassium and sulfur, barium and bromine, and sodium and phosphorus. Go to your periodic tables and write your charges and try your best to make the balanced compounds and then come back to see me. Hit pause and do your thing. So calcium's group 2, 2 plus. Oxygen's group 16, so 2 minus. They're equal but opposite. We don't cross the charges here and write Ca2O2. We reduce to CaO. Good. K is plus 1. Sulfur is 2 minus. There we go. 1 plus, 2 minus. I need 2 of my plus 1 to cancel 1 of my 2 minus. 2 times that, 1 times that. Am I crossing them and going 1 of those and 2 of those? Oh, yes. Barium's 2 plus. Bromine's 1 minus. Cross them. 1 barium and 2 bromines. And for sodium and phosphorus, 1 plus and 3 minus. Remember, I'm getting these charges from where they are in the periodic table. Sodium's plus 1 because it's in group 1. Phosphorus minus 3, group 15. Na3P. Good to go there. There aren't many polyatomic cations. Polyatomic means made of more than one atom, and it's a pretty common idea that we have groups of atoms bonded together with specific names and charges that are making compounds. But most are anions. So these are 2 polyatomic cations. You're going to see they end in IUM. H3O plus is hydronium. And NH4 plus is it's a really bad letter M. Ammonium. There you go. Monatomic anions. We're going to go right into naming anions. When I'm usually naming anions, and I did it before, I did skip. I'm sorry. Hit pause. I'm not re-recording for that. My pages were punched out of order. For ionic nomenclature, naming cations generally go back to there. Cations formed from metals have the same name as the metal. So lithium plus 1 is the lithium cation. Sodium plus 1 is the sodium cation. If cations have more than one possible charge, use a Roman numeral. Where are these cations found on the periodic table? So when do I know if I need to use a Roman numeral? They're usually in the middle. They're usually a transition metal or the bottom of group 14. Where else do you find them? On this list. You won't get this list on an exam once we're back in school, but for right now, to look at those is good. Get suspicious if it's in the big block in the center, the transition metals, or if it's in the bottom of the P block, because metals don't belong over there. They're going to need a Roman numeral in most cases. So there's some names. You'll notice I gave you what's called a stock name. It uses a Roman numeral. That's kind of the normal for these, is to use the Roman numeral. Iron 2 or ferrous, the Latin names are old. Oh, the Latin names are old. When I was in high school, my professor told me the Latin names are old. People don't like them anymore, but they haven't gone away. They haven't gone away. They're so not even used anymore, but you still get the old farts who love them. So, basically what happens there, the quick overview, if you have 2 charges you're comparing, your lowest one gets a Latin name with OUS, like ferrous. Higher one gets an IC ending, ferric. Do I use those often? Oh no, I never learned to use them. It's like the numbering 1 through 18 is what I learned and it's what I prefer. We're going to not use Latin names too much there. There are important exceptions to the rule of transition metals needing Roman numerals. You do not need Roman numerals for silver. It's 1 plus, Ag 1 plus. Zinc, Zn, 2 plus. Cadmium, Cd, 2 plus. Go with those. And now we're to this section that I decided I was going to do ahead of time with hydronium and ammonium. Sorry. Now we'll name some anions. Monatomic anions, so if I just look on the periodic table, they end in IDE. Nitride, sulfide, chloride. So F minus, fluoride. Be careful with your fluorine spelling, Fluoride. It's fluorine on the table and fluoride once it's a minus. Sulfur with a 2 minus charge. I know you've heard of things that end in different, like ATE for sulfur. Sulfide when it's just sulfur. Some polyatomic ions also have this IDE ending. OH minus, hydroxide. And this one's cool, CN minus, cyanide. This is the last thing we'll do today, and we will continue the rest of our nomenclature and practice next time through. Oxyanions are polyatomic ions that contain oxygen. They're polyatomic ions that contain oxygen. Good for you. If I only have 2, if I have 4, it's a different procedure. Check this out. A lot of times you've only got one that looks alike. If I say carbonate, you're like, maybe you remember CO3 with a 2 minus. But you might also remember seeing nitrate and nitrite or sulfate and sulfite. Different anions can form different numbers of bonds to different numbers of oxygens, and then their names are different too. So if I only have 2, like sulfate and sulfite, if I only have 2, the ATE ending goes to the higher number of oxygen, making that sulfate, and my lower number gets the ITE ending if I've only got 2. But there are some sticky ones out there. For chlorine, chlorine's nasty. You can do ClO4, ClO3, ClO2, and ClO. All chlorine with some number of oxygen, 4321. When I have 4, I use the prefix per and the ending ATE. For my highest number of oxygens, this would be perchlorate, the perchlorate ion. For the next lower, it's always 4321. You don't use per. This one is just chlorate. Next lowest, you use ITE, chlorite. And this lowest, you use the prefix hypo. Like hypothermia being a low temperature, this is hypochlorite. Perchlorate, chlorate, chlorite, hypochlorite. Are you going to need to memorize those? I'd say be able to apply that, but again, before you ever take a test on this, we'll review again. I'm stopping now for this lecture, going into lecture 10, so that I can put the problems up and you don't have to wait for me to write. See you soon.